The purpose of this video is not so much to teach you something new as to systematize something that you have already figured out by now, most likely, and that is how to construct the tangent line to a certain curve at a given point. We know that given a curve like the one on the left hand side and a point on it, we can identify its tangent line even if only conceptually. And the same thing, if we pick another point, we can construct its tangent line there. And even when we have a curve which is not the graph of a function like the one on the right hand side, and if we pick a point on it, we can identify what the tangent line is. Of course, these kind of tangent lines will probably intersect the curve in other points, but that's okay. That's something that can happen even with the graphs of regular functions. Or we can pick another point and so on and so on. So the idea is, how do we actually construct this tangent line in a quick and efficient way? Well, let's have a look at first of all what we usually have available and then what we need in order to construct the equation of this tangent line. So usually what is given to us is first of all some kind of formula which allows us to get the graph of the function if we want to, and this formula may be given through the regular function format, y equals f of x, or in the form of a parametric curve, or in the form of a polar curve, or maybe even in some other way. But we must have some formula that allows us to both sketch the graph of the function as well as compute its slope through some appropriate derivative. And then the other thing that we have to be given is a point. Now this point may be given through both of its coordinates or through some other information which allows us to get the coordinates of the point. Now what do we need on the other hand? Well, remember, what we need to find is the tangent line, right? So how do we get the equation of the tangent line? Well, the most common way of describing a line is through a slope-intercept formula. And this is something of the form y equals mx plus b. But let's reflect for a second about this formula. This formula requires us to find m. Well, that is not really a problem because m, as I said, is going to be obtainable through the formula of the curve. But what about the intercept b? Well, the intercept is there. Well, where is there? We may be able to find it by using some additional calculations, but this is not a very efficient way to do it. We don't know where that intercept is, and we may in fact prefer not to have to work to find it. So instead, what we're going to do is we're going to use a different formula for the equation of a line, namely the point slope form, the one that looks like what you see in front of you. And that makes sense, right? The point slope form requires the point and the slope, and therefore it's exactly what we have. Notice that we have the slope, as I said earlier, and we also have the coordinates of the point, or if we don't have them, we can find them, right? So those are the coordinates of our point. They are either given or easily obtainable. So this is the preferred formula that we're going to be using. So what is the strategy that we can use all the time to construct the tangent line to a curve at a point? Well, in order to find this equation, first of all, we want to identify the formula for the curve and figure out what kind of formula we have. Then we, if needed, if it's not already given to us, we need to find the coordinates of the point at which we're constructing the tangent line. Then we're going to use suitable derivative formula to find the slope. And finally, we're going to insert all of this in the point slope formula. So it's a fairly simple strategy. As I said, probably not a surprise to you, but it's just a way of systematize all the information that we've got so far.